Welcome friends to Power Plant Guru YouTube channel. Friends, I am a mechanical engineer with around 20 years of experience in the field of power plant, and I used to create small fundamental knowledge series videos for power plant engineers. We also run doubt clearing sessions on weekends. So if you want to reach us, you can reach us through comment section and join our weekend classes. Let us continue to watch our today's video.
Today's topic is auxiliary steam system, which is an essential part of any power plant where you need steam for many purposes. But this steam is not that steam which drives the turbine. So what is the difference? The difference is the main steam which drives the turbine is at a higher pressure and temperature. But for utilization of various day-to-day jobs in like aerator pegging steam or auxiliary stream required in condenser ejector system or for soot blowing, that pressure temperature is not required. Essentially, some lower pressure can work for all these needs. So we need to have a different network of steam running across all the areas in the plant to serve this purpose. So that is what the auxiliary steam which serves the different purposes in the plant. And there may be, if you can read on the slide, there may be different purposes. If you have motor-driven boiler feed pump or motor-driven fans, then you in your plant there will be turbo-driven fans as well, or turbo-driven pumps also. This reduces the auxiliary power consumption of the total plant, and overall turbine cycle efficiency also increases. So this, in like many functions are like that where you need like for pump operating the pumps and fans. And there are many systems where you have to heat those system. There will be a fuel oil tank where, for example, you can have a fuel oil is stored. Then there will be steam tracing line to maintain that tank at a some temperature. Below that, the viscosity of the fuel will change, and then the fluidity will not be maintained. So that type of purposes are there for this steam. And feed water heating, maybe HP heaters and LP heaters are required in all plant, coal-based power plant. So that is also one purpose. And then deaeration is there to remove the dissolved gases, and then soot blower and ejectors. So there are many systems where steam is required. So let us understand how this steam network is there and how it works. So I'm taking an example here in this case where you can see this is a boiler drum. So this is called a steam drum here in this case. And if you see, there's a tapping of steam from this steam drum only. So many systems will have this type of configuration where saturated steam saturated steam is taken. Why saturated steam? So you many people will be surprised that why saturated steam is taken. Normally, saturated steam tappings are not there in many plant. So those people will ask why this type of steam. So why saturated steam is taken? Because at this steam drum pressure and temperature condition, as the pressure is higher, now this saturated steam will pass through a PRDS system. PRDS system, what will happen? There will be a control valve where this steam will be passed through, and then there will be some lower pressure. Here it is high pressure and here it is low pressure. So once you do this throttling effect where the enthalpy remains same, then this side you will have your higher temperature. So temperature will increase, pressure will drop. So that is where your saturated steam temperature may be suitable at what pressure you are going to let down the steam to use in your different like heating of maybe air preheater, steam coil air preheater are there, or maybe it is going into deaerator. So that is where saturated steam is also used sometime, so that once you lower down that steam pressure, so the temperature is good and you can utilize those steam. Similarly, we have another type of network which is very yeah, here. So you have a different type of typical steam network where you have your boiler, and from boiler main steam line, main steam system supply goes to your turbine system. And then your turbine HP, MP, and LP stages may have different type of letdown. So letdown or extraction steam, maybe a controlled extraction or maybe uncontrolled extraction. So if you see the steam which first extraction is there, this line if you see, this comes to your boiler feed pump to drive your BFP. So similarly, another stream goes to your HP heater. So that is why there are different after this let's say we have a turbine, and there will be certainly different stages where turbine blades are there. So once you have put that steam here and it has passed through these stages, and then you have a extraction. So this extraction will have certain pressure which is lower than this, and after that you have another extraction similarly, and all these will have lower continuously, pressure will go down as it is reaching towards the last stage. So accordingly, what is the need heat requirement of that particular equipment, in that series or sequence only this extractions are placed. So if you see after this boiler feed pump, there are HP heaters which we were talking about in previous slide. So after BFP it is there, so their for feed water pressure will be very high. So that is why it is called, these are called HP heaters. And before putting the before the boiler feed pump, there are also heating being done, although that are from the lower pressure end of the extraction. And water is also before boiler feed pump. So here the feed water pressure will be comparatively very low. So that is why these heaters are called LP heaters. So this type of system is there, for auxiliary steam. And similarly, if you see deaerator also, there is a deaerator where this feed water is coming, and here you have your extraction from turbine where you have steam coming in for deaeration purpose. But what if when the turbine is not started, then how this deaeration will happen? So for that purpose also there will be a supply to this deaerator from maybe different auxiliary steam or maybe from other boiler system or auxiliary boiler system, so that it gives a startup flow requirement fulfilling steam requirement, so that you boiler can start. And then once the boiler is up and running, then they start rolling the turbine. And after that, when the turbine is also stable, then slowly this pressure will increase, and this turbine extraction will act here as a bagging steam. And this bagging steam originally which was coming from our auxiliary system, this will be stopped. So this will be only in a startup condition, startup or maybe shutdown. So that is how this system is designed. And this is a very brief on auxiliary steam system, how the network is there, and how there may be different plant where the different setup is also there. In many plant, what will happen? There will be a battery of boilers, maybe two, three boilers, where all boilers main steam line is there, and then you have one turbine here, another turbine here, and another turbine here. So then maybe I'm drawing a very simplistic diagram: B1, B2, B3, and B4. So here also this may be one your steam taken to create a PRDS or auxiliary stream. So this network will be alive whenever any boiler is running. Let's say B1 is down, so B2 is up, B3 is up. So this line is charged. And wherever you want a steam for boiler startup. So that also you can take. If you want turbine 2 startup, then also you can take. So some common header type of arrangement is also there in many plants. So different configurations are there, and that serves the purpose of auxiliary steam. So this is a small video on this topic. If you have any question, feel free to ask in comment section. Thank you very much for being with us. Thank you for watching Power Plant.